we have the cube root of x over the square root of x. It's said to write it with rational exponents. So that means not radicals. So a cube root is the same as what power? And the square root is 1/2. So now we have to think, if we are dividing, what do we do to our exponents? Subtract. When we're dividing, we subtract them. If you do 1/3 minus 1/2, what does that give you? A -1/6. And a negative means it goes on the bottom. And I said to write it with a positive rational exponent. So that's how we knew we had to go ahead and move it to the bottom instead of leaving it as a negative power. All right. Number 9. All right, so we need the square root on one side and everything else on the other. If you prefer to make it positive, you could add your 1 over and add your square root. You don't have to, but then you don't have all the negatives to deal with. So it's just a little prettier. When we square, to get rid of the square root, we are doing each side of the equal sign. So on the left, when I square, that means I have the entire parenthesis twice. So we have to FOIL. So we get x squared plus x, so plus 2x plus 1. And over here, square root, those drop, and we just get x plus 3. So if we bring everything to one side, so what multiplies to -2 and adds to +1? If we set those equal to 0, we get a -2 and a +1. But we are not done. Any of these problems where we start squaring, we need to check our answers. Okay, so we are plugging those into the original. If I put in a -2, so we get a -2 minus the square root of 1. So that's -2 minus 1. Does that equal -1? No, that gives me -3. So -2 does not work. If I put in 1, I get 1 minus the square root of 1 plus 3. So 1 minus the square root of 4 is 1 minus 2, which is -1, and that works. So 1 is the only answer. Make sure you are checking on that. You don't necessarily have to show all the work for how you checked, like writing it out, because you are welcome to do it on a calculator. However, if you fail to remove a solution that doesn't work, you are going to be losing points. All right. Number 10. What does a 2/3 power mean? Okay, a 2x to the 1/3 means 2 times cube root of x. Alright, we can try adding an exponent, but to get rid of a cube root, we would have to cube. And since I have multiple cube roots, we would end up cubing multiple times, and it's going to get very ugly very fast. Are there any other ideas? Yeah. We can't do necessarily greatest common factor, but we always, if we think about setting it equal to 0, so you can keep it as the radical, you can write it as a 1/3, whatever you're more comfortable with. If I subtract my 3, we have something squared. We have the same thing as the first. We have a constant. So this is like a quadratic. If you have a cube root squared, then each parenthesis would get a cube root. So now you're just asking yourself, what multiplies to a -3 and adds to +2? So now we set those equal to 0. So we get the cube root of x equals -3. To get rid of a cube root, we cube each side. And so that gives us -27. Here, cube root of x plus or minus 1 equals 0. So the cube root of x is equal to 1. Cube each side, and we get 1. Are we done? Check it. Okay, you're welcome to use a calculator, whatever you need to do. -27 to the 2/3 plus 2 times -27 to the 1/3 needs to equal 3. Okay, so that's like the cube root of -27, which is -3. -3 squared is +9. -3 times 2 is -6. And 9 minus 6 equals 3. So that one works. If we check for 1, it's 1 to the 2/3 plus 2 times 1 to the 1/3 plus 3. So 1 to any power is still 1. So 1 plus 2 equals 3. And this time they both work. And we know it's possible that they both work. It's also possible that neither one works. So you always have to check everything. Do we need to look at 11? Maybe 3 halves and 2. Let's check number 12. Alright, if I want to get rid of a square root, we need to square each side. The square root and the square cancel. So we have 2 times the square root of 7x plus 2. Over here, those cancel. We get 3x plus 2. So we still have square roots. You're welcome to divide by that too, but it will give you some fractions. So if you want to keep it, that's fine. We have to square a second time. And so when you square this, it's saying you have 2 times the square root times 2 times that square root. So 2 times 2 is 4. So you square the 2. Square root of 7x plus 2 times itself would drop the square root and give us 7x plus 2. Over here, we have the 3x plus 2 twice. So if we FOIL, we get 9x squared plus 12x plus 4. So multiply out, move everything to one side, so that gives me 9x squared minus a 16x minus 4. Do we have a greatest common factor? No, so what do we do? So that's x squared minus 16x minus 36. So multiply to -36, add to -16, -18, +2. Then divide by 9. So 18 over 9 is 2. Slide the 9 back in front, so 9x plus 2. Set those to 0, and we get a +2 and a -2/9. Are we done? Check them. Okay, always go back to the original. If you put in a 2, that would be 14 plus 2 is 16. Over here, 6 plus 2. So the square root of 16 is 4, times 2 is 8, so we get the square root of 8. Did I make a mistake? Yeah. This is stuff I had in myself. Equals the square root of 8. So that one checks. if we put in the -2/9, this one is not going to be pretty, so it'd probably be easiest just to do it on your calculator. So why don't you guys put -2/9 into the right hand side of the equation, and you guys put it into the left, and let's see if we get the same decimal back.
Say right side.
Yeah, the square root. You guys get the double square root side. Okay. Did you guys get the same thing? Yes. So they both are equal, and both answers work. 13. How do we rewrite x to the 2/3? Okay, so what did you guys do first?
Cube everything.
Alright, it doesn't really matter if you get rid of the cube root or the square first, but you probably did start with the radical. So if you cube, 25 cubed is 15,625. Now we add a square root. When you do a square root, you have to do a plus and minus with it. And what is the square root of 15,625?
125.
Positive negative 125. And you don't have to on this one, but you certainly could check it just by putting them back into the original. Just make sure when you do that, it goes in parentheses. So you do 125 to the 2/3 in parentheses, negative 125 to the 2/3. And they both turn out to
Yeah, I was
equal
trying to get one and I forgot the parentheses.
So you
It doesn't
probably
work anymore.
thought the
Oh, wait,
negative.
no, it works, I forgot.
Next question we had was 22. You guys don't want to go over any of the inverses? Okay, so we have the same base on each side. Instead of the square root of 3, we would write it as 3 to the 1/2 power. And so now, if the base is the same, you can drop it and set your exponents equal. Okay, quadratics, we always set equal to 0. But we don't typically see fractions within them. So how can I fix that?
Oh, multiply for.
Yeah, or, I mean, a lot of people, when I was talking to them, they went ahead and just multiplied everything by 2 to get rid of all the fractions to start with. There's different strategies. So if you went ahead and did your slip and slide, you get there as well. So either way, whatever you are most comfortable with, if you did this, either way, then we're back to slip and slide problem from here. So that gives me x squared plus 2x minus 8. So that would multiply to x plus 4, x minus 2. But then we have to divide by 8. So 4 over 8 is 1/2, so that's 2x plus 1. 2 over 8 is 1/4, so that's 4x minus 1. Okay, if you'd went straight into the slip and slide from here, then you have x plus 2, x minus 1. Divide by 4, so 2 over 4 is 1/2, so that's 2x plus 1. 1 over 4 is 1/4, so 4x minus 1. So we get the exact same thing. It's just a matter of if the fraction really bothered you, you could get rid of it altogether. So either way, now we set it equal to 0, and we get a negative 1/2 and a positive 1/4. Do we have to check on these? good idea. You're not going to get answers that don't work as long as all of your steps are correct. But it doesn't take too long, so that's a good way to ensure that you have the right answer. So we shouldn't be getting extra ones, but we could take the time to double check that what we have is correct. Number 24.
Oh, I see what they did.
So first we have to decide what we're going to use for our common base. Can I break down 2/3? No, so let's just leave it. Alright, so that means I need this one to be a base of 2/3. So 81 is the same thing as 3 to the 4th. 16 is the same as 2 to the 4th. So we're looking at a 4th power, except we need to flip this because we need the 2 on top. So it has to be -4. And that was all to the x plus 1 power. So now, power to a power, what do we do? Multiply, so that's -4x minus 4. So now you can set the exponents equal to one another. So if we add over our 4x, add over the 1, and divide, we get a -3 this. And of course you can check by plugging it back in. What about the inequalities? Do we need to look at any of those?
On 26, because it. Can you just look at one?
Sure. The thing to remember for the inequalities, it's the same as the equations if what is true.
It's not greater. It's greater than 1.
Base has to be greater than 1. So the equation, it doesn't matter what you use for the base. For the inequalities, you need to use a base greater than 1. The reason is if you don't, then it actually, we know that if the base is less than 1, then it's decreasing, so it would flip our inequality. So rather than trying to remember if you have to flip your inequality or not, just make both sides have a base greater than 1. Let's look at 28. An investor has $40,000 to be invested for 3 years. So we have 40,000. What variable is that? P, what we have right now. And 3 years, so my time is 3. Remember, time always has to be measured in years. So if I said like months or something, you would have to convert it. Which of the following plans would be the better option? So if you are investing, do you want more or less money at the end? More. If you were taking out a loan, would you want more or less at the end? Less, because you would want to pay back less. So the better option depends on the scenario. Is this money you're making or money you're paying? All right, so plan A is your interest rate is 5%. Okay, or sorry, 0.5%. So that's still a percent. When we do this, we have to do it without the percent, so it always moves your decimal back 2. So the R is 0.005. Compounded quarterly, so my number of times a year would be 4, and we are looking for our final amount. So the formula is A equals P, 1 plus R over N, P and T. I told you I would give you the formula in a test, but I'm not going to tell you what anything stands for. So we don't know A. P is 40,000. 1 plus 0.005 over 4 to the 4 times 3 power. So everybody plug this in, make sure you remember how you can get the right answer. And this is money, so we'll go to 2 decimal places. Alright. So that's plan A. Plan B, the interest rate is 0.4%, so we'll do 0.004. Compounded continuously. When we see continuously, that means we are using the other formula. A equals P e to the RT. So B is still 40,000. E to the 0.004 times 3 power. So if we put that in, remember E is if you do second and the natural log button. So our ending amount is $40,482.89.
I have, 40,604.52 cents.
Because you did 0.005.
Oh, four. Oh, okay.
So which one is better? A. You would end with more money. So that's the one we should go with. Alright. So those are all the questions you. So let's say we have a function. Alright, if I asked you to find the inverse, what is the first step? And then what do we do?
Switch X, Y.
So since I have 2 x's, now I get 2 y's. Now we're trying to solve for y. So first step is to get rid of the fraction. So we can multiply over the y plus 3. So that would give us an xy plus 3x equals 2y minus 5. If I want to solve for y, I need to get these y's on the same side. So you could subtract over the 2y. We need to move the 3x over. So we get here. Is everybody okay there? Now what do we do?
Factor out the Y.
Gotta get y by itself, so if we factor it out, and then we can divide. Now on our quiz, a lot of you missed, what is the final step? What do I want you to write?
F of X. F
Yeah, just to label, this is the inverse. Okay, we know the domain of the original. Those are the x's in the original. They become the y's, so those become the range of the inverse. Some of you also weren't labeling those. You just said D equals R. It's not true that the domain is just equal to the range. You have to tell me the domain of this function is equal to the range of this one. So make sure you tell me what's what. Domain is what x can be. So if I look back, we're talking about domain of the original. If I look at the original, we know if it's a fraction, the bottom can't be 0. So what can x not be? So it would be negative infinity to negative 3 union negative 3 to infinity. Now the range of the original function, that's a little harder to identify, but I know the range in the function, the y's in the original, become the x's, so that's equal to the domain of the inverse. So it's easier to find the domain of the inverse. If I look at my inverse, we have a fraction, we know the bottom can't be 0, so it's everything except 2. When you guys did like problem 17, did we have any fractions in the original? No, so the domain of the original was negative infinity to positive infinity. Now the inverse had a fraction, but the denominator was just 4, And 4 is never 0, so it also turned out to be negative infinity, positive infinity. What else? So if I gave you this problem, what do I need to pick for my base? 3. Why am I going with 3? Right. We could go with 1/3, but we don't want fractions, so we're going to go with 3. So 1/3 is 3 to the negative 1. 81 is 3 to the so this is 3 to the negative 2x minus 1 is less than 3 to the 16x minus 12. So now, since my base is bigger than 1, we have the same base on each side, we can just drop that. So if I subtract over my 16x, add over my 1. When you divide by a negative, what happens? Okay, x is greater than 11 over 18. So greater than means everything's bigger, no equal to, so we do a parenthesis. So 11 over 18 to positive infinity. Is that one okay? I'm going to give you guys a problem I want you to try. What would we do first here?
I added over the square root of x plus 6.
Okay. We can only get rid of one square root at a time. So if you add the other one over, I'm just going to put it in front, so it's the square root of x plus 3 minus 1. But if you wrote minus 1 plus the square root of x plus 3, that's fine. So now if we want to get rid of a square root, we have to square. And we square each side. So on the left, the square root and the square cancel. That just gives me an x. But on the right, we have to think there are 2 of these. Radical x plus 3 times radical x plus 3 would just be x plus 3. Radical x plus 3 times negative 1 is negative radical x plus 3. Plus negative radical x plus 3 would be negative 2 radical x plus 3. Negative 1 times negative 1 is positive 1. So if I combine like terms, what happens if I subtract my x? So I could add over my 2 radical x plus 3. What could you do now? Square it. And if you wanted to, before you squared, you could divide by 2. Either way, we would get the same answer. So if I divided by my 2 first, now if I square, I get x plus 3 equals 4. Subtract my 3 and x is 1. So then make sure we check. If we plug in a 1, square root of 1 minus the square root of 4, so 1 minus 2 is negative 1. So it does work. So if we have multiple radicals, we might have to square multiple times. And remember, if it's in multiple terms, that means you have to FOIL. We have about 5 minutes. Is there anything else you want me to go over?